In this video, I'd like to talk to you a little bit about section 1.5 and the use of parameters. Parameters are going to be another way to define functions. Or relations. So what we'll do is we will define both elements. I'm sorry, this may be kind of hard to read. Of the ordered pair XY in terms of another variable. Another variable, which we're going to call t. Okay, and that t is what we're going to say is called our parameter. Okay. All right, so we are going to do a little example here. So let's say, consider the set of all ordered pairs XY defined by the equations. Guess my equations didn't come on here. Might be helpful to know that. Okay, so let's put those on. You never know when you upload things. Okay, so let's say that X is equal to T plus 1. And we're going to define Y to be T squared plus 2t. Okay, where t is a real number. Okay, I copied that part, so that's good. All right, so first thing we're going to do, we're going to pick some values to plug in for our t. Okay, so as you can see here in the chart, I've already plugged those in for you. -3, -2, all the way down to 3, we're going to plug in here. So the first x, for example, we're going to do -3 plus 1. And that's going to come out to be -2. Okay, the next x we're going to do -2 plus 1 comes out to be -1, and so forth. So we're just going to plug these values in for t and do the little calculation. So the values we get are as such. Then we're going to do the same thing over here for y. So to calculate y, we're going to do like -3 squared plus 2 times -3. Okay, and if you do that calculation, it'd be 9 plus -6, and you get 3. And again, we're just going to go through and fill those in. And I'm just going to fill in the chart for you, but that's how I'm coming up with those values. So then what we have at that point are the ordered pairs, -2, 3. So x, y. -1, 0, 0, -1, 1, 0, 2, 3, 3, 8, and 4, 15. Okay, so now we've generated a set of ordered pairs. Okay, so that part's done. All right, so now to determine the relationship between x and y, and then we want to see if y is a function of x. Okay, so now we're going to take and solve for t in terms of x. So if we know x equals t plus 1, and we solve for t, t is going to equal x minus 1. Okay, we're going to take that x minus 1 and substitute it into the y equation. Okay, so it's going to become y equals x minus 1, the quantity squared, plus 2 times x minus 1. All right, so this is going to generate our function. So we get x squared minus 2x plus 1 plus 2x minus 2. And when you collect like terms, you end up here at y equals x squared minus 1. Okay, so then if you plug this in your calculator and generate a graph, okay, you're going to have a parabola that's down 1, and it opens up. Okay, so if you check these points down here that we've generated, it in fact will satisfy our function. Okay? All right, so next we have a second example. Okay, going to go through the same process. It would be helpful if I had these copied here. The function, or the two equations I had for us were x equals t plus 2 and x equals 2t minus 1. Okay, so again, we are looking to find the relationship between x and y, and is y a function of x? Oh, my bad, I didn't answer that in the first one, did I? Is y a function of x? Yes. Okay. All right, so let's complete our table first. So again, we're going to plug the t values in to calculate your x and your y. Okay, so first, -3 plus 2 is going to give you a -1. Okay, the next one, -2 plus 2, you get 0. Okay, and then I think from there you could figure those out, filling in the table. Then repeat, do the same thing for y. So like 2 times -3 minus 1. So -6 minus 1 gives us a -7. Okay, and then we'll do all the y's. So -5, -3, -1, 1, 3, 5. And then together, we pair them up, we get our ordered pairs. -1, -7, 0, -5, 1, -3, and so forth. Okay, 3, 1, 4, 3, 5, 5. Okay, so next thing we're going to do is to solve for t in terms of x. Okay, so if x equals t plus 2, that means t is going to equal x minus 2. Then we're going to substitute that into the y equation. So we'll have 2 times x minus 2, the quantity, minus 1. So 2x minus 4 minus 1 is going to give us 2x minus 5. Okay, and then if we were to create a graph over here, we're going to be down here 5. Okay, so down 5, your slope is up 2 over 1. And you have a little line. If you check a couple points here, like if you check up here for y equals 2x minus 5, and you substitute in -1, and look at that, you get -2 minus 5 is in fact -7. Looks like we're in business. Okay, things are looking good. All right, so if we were in class now, I would pause and let you try the third example and see if you could work through there and get the correct answer. So if you'd like to pause the video right now and try this one and then turn it back on and see if you did it correctly, that would be fabulous. Okay, so again, I lost my equations here. So if you hit pause, I'm going to keep working. You can come back in and join me in a minute. All right, so our x and y equations in terms of t are given like so. Okay, so again, I'm going to plug in the t value to generate my x's. So 2 times -3 gives me -6, and so forth. So you should have -6, -4, -2, 0, 2, 4, 6. All right, then I'm going to substitute the same t's into y, and I get 11, 6, 3, 2, 3, 6, 11. And again, these are then generating our ordered pairs. -4, 6, -2, 3, 0, 2, 2, 3, 4, 6, and 6, 11. Okay, so then we have x equals 2t. We want to solve for t, so divide both sides by 2. So I get t equals x over 2. We're going to substitute this value in for y, or in the y equation, sorry, for t. So x over 2 squared plus 2. So we get x squared over 4 plus 2. Okay, and if you drop that in your calculator, take a look at that, you get a great big wide parabola. I keep forgetting to answer the question, are these functions? Yes, that's going to be a function. Let's see here. The previous one, yes, a line's going to be a function. Okay, and that's what you should have come up with your answer there. Couple extra vocabulary words down here at the very bottom. Let's change up color because I like color. All right, so a relation. If we have the word a relation, it's just a set of ordered pairs. Okay, so any set of ordered pairs, you could have a little set notation, you know, 2, 3, 4, 6, 0, -8, whatever the case is. Okay. Inverse relation is when you're going to reverse the coordinates of the ordered pairs. Okay, in a relation. Okay, and then last thing I have on this page of notes is graphically use the VLT to determine if a graph represents a function. Use HLT to determine if the inverse of the graph is a function. Okay, so HLT is just the original graph. Is it a function? HLT is going to determine the inverse. Okay, so, excuse me. If I put this down underneath here for a minute. Okay, I'm going to mark that out. Okay, so if we have a graph down here, I don't know, something like this. Okay, and I want to know, first of all, is this graph a function? I'll call this A and B, so it's a little less writing here. So A, I'm going to say yes, it's a function. Yes, function by VLT. Okay, because if you draw, you know, your vertical lines, it only hits a graph one time. B is the inverse of function. Well, try horizontal line test and see. Well, look at that. It only hits the graph one time. So yes, the inverse is a function by HLT. Okay, let me sneak another one up here. Sometimes on the video it's hard to fit everybody. All right, let's say we have something like this. Okay, is this thing that looks like a circle A, is it a function? We'll say no. It fails VLT. As soon as I start drawing vertical lines, not working. Okay, secondly, is it going to be the inverse of function? If I draw horizontal lines, nope, we're hitting twice. So inverse, not function by HLT. Okay, maybe one more. I've got room here for one more picture. Let's do something a little different here. How about one this way, put a curve this way, and a curve this way. All right, so question is, A, is the original picture a function? And my intent was to say yes, it's a function by VLT. Okay, so these parts here are not supposed to hit. My artwork's fabulous. All right, and then secondly, is the inverse a function? Inverse, not function. Because again, the horizontal line test, it's going to hit the graph twice. Yeah, so the inverse is not a function by HLT. Okay, I think this concludes our video for today, a section 1.5 with parameters and a little bit of VLT, HLT work to determine if a graph is a function and whether or not an inverse is a function. I hope you find this video helpful, and I look forward to seeing you in class. Have a good day.